So in this section, we're still in section 1.6. We're going to talk about how to solve equations involving rational exponents. And before we get too deep into this, I just want to remind you guys of what on earth a rational exponent is. So when we say rational exponents, we mean exponents in fraction form, right? So when we talk about these rational exponents, I think of these rational exponents as a power over a root. Power over root. Okay, so just as a warm-up up top here, I ask you guys to simplify 8 to the power 4/3. So let's go ahead and simplify that. And just for simplicity, I find it much easier to do the root first and then the power second. You can actually go in either order with these. If you take the cube root of 8 first, it dwindles down to a 2, and then you can raise that to the 4th power and get your 16. Going the other direction, 8 to the 4th power is some really big number. That would be 8 to the 4th equals 4,096. I don't know that off the top of my head, but I do know that the cube root of 8 is 2. So I like to take the root first and then apply the power second. All right, so to simplify this guy, first I'm going to take the cube root of 8, and then whatever that is, I'm going to raise it to the 4th power. I know the cube root of 8 is 2, and when I raise 2 to the 4th power, it gives me 16. So fully simplified, 8 to the power 4/3 equals 16. And let's try this again with this next example, 25 raised to the power 3/2. So again, I'm going to take my root first. The root 2 is a square root, so I'm going to take the square root of 25 and then raise it to the power 3. I know the square root of 25 is 5, and then when I raise that to the 3rd power, that gives me 125. Okay, and of course, if you don't know these off the top of your head, the square root of 25 on your calculator, you can use your square root key over that x squared button using your second key. So there's 5. Use the caret symbol, 5 raised to the power 3. So in your calculator, it's 5 raised to the power 3, and that gives you your 125, just as a reminder. Oops. 5 raised to the power 3. That looks better. Okay. All right, so what we're going to be looking at are equations like this guy. Over in the top left, x to the power 3/2 equals 27. So we want to solve this for x. And over here on the left, I wrote out our steps to solve. So the first step is to isolate the term that contains the rational exponent. And this is already done. So if we had like x to the 3/2 and then like minus 5 equals whatever, we would add 5 to both sides to isolate that term. But ours is already isolated in this equation, so we don't need to worry about that. Okay. Second step, we're going to raise both sides to the reciprocal power. So I want to show you guys why we're going to do what we're about to do. So another quick review, okay, before we do that step. Remind me what x squared raised to the 5th power is. If I were to simplify that, I would get x to the 10th, right? And what did you just do to get that power of 10? You multiplied your exponents, right? Multiply your exponents. So that's the power rule, right? So we have x to the power 3/2 equals 27. I'm going to raise both sides to the reciprocal power 2/3. 27 to the power 2/3. And that brings us down to this line, right? So how does that help us? Well, by the power rule, if I take x to the 3/2, raise it to the 2/3, I'm going to multiply these exponents together, right? And what happens when I multiply 3/2 times 2/3, a fraction by its reciprocal? I get 1. So on the left-hand side, I have x to the 1st power, which of course is just x. So I've isolated x on the left. Over on the right-hand side, we'll need to simplify 27 to the power 2/3. And you can see I do that in this step. So first I take the cube root of 27, then square that. The cube root of 27 is 3. When I square 3, I get my final answer of 9. And then you'll want to check your answer in the original equation before you touched it. So I got x equals 9. Let's check x equals 9 to make sure that that works in this equation. So this is saying that 9 to the power 3 halves should equal 27. And to simplify on the left, that means I would take the square root of 9, raise that to the third power. And I know the square root of 9 is 3. When I cube that, I do get 27. So my solution of 9 checks out. Okay, so let's apply that to number 7, that same process. X plus 5 to the power 3 halves, already isolated, so I don't need to do anything, in terms of like adding or subtracting values. So now I'm going to get to that step where I raise both sides to the reciprocal power. So I'm going to raise the left side of this equation. Because I already had the power 3 over 2, I'm going to raise it to the power 2 over 3. And I'm going to match that on the right-hand side as well. I'm going to have 8 to the power 2 over 3. So on the left-hand side, I know that those two powers, the reciprocal powers, when I apply the product rule and multiply them, I end up with a 1. That means they cancel out in terms of exponents. They cancel out to a 1. So I just have x plus 5 on the left. On the right-hand side, I want to go ahead and simplify this. So I have the cube root of 8. I'm going to raise that to the second power. So this would be 2 squared, which gives me 4. So I have x plus 5 equals 4. Subtract 5 from both sides. I solve and get x equals negative 1. All right, let me go ahead and check x equals negative 1 to make sure that it works. And when I check it, remember that I'm checking in this original equation before I started messing with it. So I'll have negative 1 plus 5 to the power 3 halves equals 8. Negative 1 plus 5 is 4 to the power 3 halves equals 8. And simplifying on the left, this would be the square root, of 4 raised to the power 3. See if that equals 8. And the square root of 4 is 2. 2 raised to the power 3. At this point, I can see that it checks out and it does equal 8. Okay, so let's put a little twist in this. We haven't explicitly noted this, but so far we've only been working with examples that had odd numerators. So odd numerators in that rational exponent. My numerator of 3, 3 over 2. 3 is an odd number. In number 7, my numerator of 3 and 3 over 2, 3 is an odd number. That makes our lives easier. Down here, we're going to see our first example where we have an even number. Even numerator in our fraction. And this is going to complicate things a little bit. So before we get into this example, I want to remind you guys that we've kind of already seen this in a way. So over here, just as a reminder, if we were to solve the equation x squared equals 16, because I have that variable squared equals a constant, I can apply that square root property, that plus or minus rule. So when I take the square root of both sides, I need to remember to put that plus or minus in front of my square root of 16. So I would get x equals plus or minus 4 as a solution, right? So we've done this before. We've already seen this. So I just want to point out that x to the power 2, isn't that the same thing as x to the power 2 over 1? So if we write it kind of like we have a rational exponent, the numerator, 2, is even. I have an even numerator. That means I'm going to use my plus or minus. Okay. So in this example here where it says x to the power 2/3 equals 16, my 2, my numerator in the fraction, is an even number. 2 is an even number. So I know that I'm going to be using my plus or minus. So even as you're working this out, as soon as you remember that you have that even numerator, so the 2 is an even numerator, you might just want to write plus or minus just over there to the side to give you guys a visual reminder to do that. So we have x to the power 2/3 equals 16. I'm going to raise both sides to the power 3 halves to the reciprocal power. So that's what we do over here. And we'll also raise 16 to the reciprocal power. But when we do that, as soon as we raise it to the power, which is, by the way, taking the square root of the constant, that's when I have to tack on my plus or minus. So on the left-hand side, I just have plain old x. On the right-hand side, I have plus or minus the square root of 16 raised to the third power, which is plus or minus 4. Square root of 16 is 4 raised to the third power, which gives me my two solutions, positive 64 and negative 64. Okay, so let's check and make sure that these both work. We have to check each one. And remember, we're going to check using the original equation. So if I check x equals 64, 64 to the power 2/3, make sure that that equals 16. So this would be the cube root of 64 squared equals 16. I know the cube root of 64 is positive 4, and when I square positive 4, I get 16. So positive 64 works. Now let's check x equals negative 64. So negative 64 raised to the power 2/3 should also equal 16. This is the cube root of negative 64 squared equals 16. And the cube root of negative 64 will actually be a negative 4, right? Remember that positive 4 cubed equals positive 64. Negative 4 cubed would equal negative 64. So the reverse is true. The cube root of negative 64 gives me that base of negative 4. And then if I have negative 4 in parentheses and square it, I get my positive 16. So negative 64 works as well. Okay. So I'm just going to amend these steps that I wrote over here. Step 1, isolate. Step 2, raise both sides to the reciprocal power. And I'm going to add a little note. If you have an even numerator, I'm just going to put even numerator, you use your plus or minus when you're raising the right side to the reciprocal power. Okay, so that's our new addendum to this rule. So if we see an example like number 8, x plus 5 to the power 2/3, the minus 1 equals 3. First, I need to isolate this. This is the first example where I need to isolate. So this gives me x plus 5 to the power 2/3 equals 3 plus 1, which is 4. Next, I'm going to raise both sides to the reciprocal power of 3/2. But when I do this, because my original equation had an even numerator equals 2, so a numerator of 2 or 4 or 6 in that fraction, that means I'm going to be using my plus or minus. So over here on the right, where I have 4 raised to the power 3/2, I need to include that plus or minus. So on the left, I just have x plus 5. On the right, I have plus or minus 4 to the power 3/2, which I'm going to start simplifying as the square root of 4 raised to the power 3. So this is plus or minus 2 raised to the power 3, which is plus or minus 8. So now I have x plus 5 equals plus or minus 8. All right, so if I use the positive sign on the right, I have the equation x plus 5 equals positive 8. Subtract 5 from both sides, and I get x equals 3. If I use the negative sign on the right, I have x plus 5 equals negative 8. And when I subtract 5 from both sides, I get negative 13. Let's go ahead and check both of those just to make sure that they each work. Let's check x equals 3. In the original equation, 3 plus 5 to the power 2/3 minus 1 should equal 3. This is 8 to the power 2/3 minus 1 equals 3. The cube root of 8 raised to the power 2 minus 1 should equal 3. So 2 squared minus 1 should equal 3, which means 4 minus 1 should equal 3. So that works. Awesome. Now let's check x equals negative 13. Negative 13 plus 5 to the power 2/3 minus 1 should equal 3. Negative 13 plus 5 is negative 8 to the power 2/3 minus 1 equals 3. So the cube root of negative 8 raised to the power 2 minus 1 should equal 3. The cube root of negative 8 would be negative 2 raised to the power 2, should equal, negative 2 raised to the power 2 minus 1 should equal 3. And this will be positive 4 minus 1 equals 3. So that works. So negative 13 works as well.